Okay, so now let's suppose we're doing mole conversions, but instead of using grams and moles, we're going to use particles and moles. Remember, a particle can be an atom, an ion, a molecule, or a formula unit. So in this situation, you'd have a problem like this. Let's change 8.43 times 10 to the 25 molecules. Now, MLC is my abbreviation for molecules. It is not official. I just didn't want to write the whole word out. 8.43 times 10 to the 25th molecules of, let's do C2H6, changing 2 moles of C2H6. Okay, so let's do this problem. Just like before, what we're going to do is we're going to write the number in the first little, I'll call it a box, even though it's not a box. So I'm going to start right here, and I'm going to put 8.43 times 10 to the 25 molecules of C2H6 in this first little box. All right? Well, now molecules is a particle. That tells me use Avogadro's number. All right? Any particle, you'll use Avogadro's number. And since I want particles to cancel out, and Avogadro's number is written as 6.02 times 10 to the 23rd particles per mole, I want my particle to be on bottom because I want it to cancel out. Molecules is particles, so I'm putting that in for that, per mole. And this is still a C2H6. Notice I gave you this compound right here, but I didn't look it up on the periodic table because I am not using grams. So if grams is not in the problem, you don't need to look it up on the periodic table. All I have to do is do my math now. So since I have one number on top and one number on bottom, I'm going to divide. So I'm going to say 8.43 times 10 to the 25th divided by 6.02 times 10 to the 23rd, and that comes out to be 140 moles, or 1.40 times 10 to the 2 moles of C2H6. Okay, now I'm going to change the page, and I'm going to go from moles to molecules. So let's say we have 1.32 moles of oxygen, and oxygen is a diatomic molecule, so that's why it's O2. And I want to figure out how many molecules of oxygen that will be. All right, so again, I'm going to start with 3.2 moles of O2 in the first box. Since I'm going to a particle, I'm going to use Avogadro's number. Avogadro's number right here, molecules, it's going to be particles per mole, so that'll be 6.022 molecules over moles. Since I want mole to cancel out, I'll put my 6.02 times 10 to the 23rd right here. Remember, that's my abbreviation for molecules. It's not official. For mole of O2 right here. Notice that mole of O2 cancels out. I have the two numbers beside each other. Since the two numbers beside each other, I'm going to multiply. So 1.32 times 6.02 times 10 to the 23rd equals 7.9, and I'm going to round up to 5 times 10 to the 23rd molecules of O2. And that's an example of how to do moles to molecules, or molecules to moles, or any kind of particle. Remember, particles can be atoms, ions, molecules, or formula units. Notice that even though I gave you O2, that I did not have to use the molar mass from the periodic table, because grams is nowhere to be found in either one of these two problems. So good luck with that. And the next video we'll do a combination. Thanks.